going to look at revision, which is on measurements, the topic measurements, the first topic in physics. So I'm going to start from 2015 to 2019. Okay, so without any further ado, let's look at the first question. Okay, so let's look at we're going to do mechanics. Thanks Frost for commenting. Yeah, love for support. Okay, so let's look at measurements. We're going to revise on measurements from 2015 up to 2019, which is pure physics. Okay, so without any further ado, let's start our discussion. So the first question, let's look at the first question. Frost, is it clear, the question there on the other side there, is it clear? Okay, so I'm going to read the question. If the question is clear, guys, kindly comment. If you're able to see the question on the other side there, kindly comment. All right, thank you. So the question reads, figure 1.1 shows a simple pendulum suspended from a clamp stand. The bob is pulled to one end at position A and oh, not clear. Justin Chidui is saying not clear. Is it the voice or the question which is not clear? Which is not clear? Can it be specific? Which is not clear, the question or my voice? Justin and Abraham. The question. Oh, okay. Okay, thank you. Let me just try to. How about now? Is it clear? How about now? Is it clear? Abraham and Justin, is it clear on that side? Abraham and Chidwi, is it clear? Abraham and Chidwi, is it clear the question, guys, there? Those are saying the question is not clear. Okay, it's now clear. Thank you. So we're going to revise on measurements, questions from 2015 up to 2019. So the first question is from 2015, section A. So as usual, section A carries 50 marks. Okay, so let's see. Read the question. So the question reads, figure 1.1 shows a simple pendulum suspended from a clamp stand. The bob is pulled to one end at position A and then is released. Okay, so we have our pendulum right there. And this pendulum is put from one end, then it's released. So the first question reads, what energy changes takes place between A and B? What energy changes takes place between A and B? So here our answer will be, hope you can see there, guys. Our answer, the energy changes which will be there is potential energy will change into what? Kinetic energy. then it will go back to what? Potential again. Potential energy. So that is the energy changes which should be there. So potential energy will be, it will change from potential energy to kinetic energy, then back to what? Potential energy. Okay, so having studied that, let's look at the next question. So the next question is B. Question 1B. So the question reads, describe briefly how you would use a stop clock to determine the period of the pendulum. Okay, so using a stop clock, how can you use to determine that the period of the pendulum? So you need to know that period is equals to what? If you want to find period, if you want to calculate period is equals to time taken over the number of what? Over the number of complete oscillation. So what we're going to do here, first of all, you're going to position the bulb at A, which is at this point. You're going to position the bulb at this point. Then you're going to release this bulb so that it should move from point A to B. Immediately the bulb is starting to move, you should also start your your clock. Then as the ball is moving, it reaches point B, then it will go back to point A. That will be one complete oscillation. Then you record the time. Then you repeat this process for several times so that you can get your a correct reading. I hope it's clear there. Then moving on to question C. So question C reads, the following values of time for 20 oscillations were obtained. The following times of 20, for following values of 20, the following values of times for 20 oscillations were obtained. So here, I hope you can see there, we have 16.1, 15.9, 16.0, then 16.2, and 15.8. These are the following times which are obtained for 20 oscillation. Now the question goes on saying, determine the period of the pendulum. Determine the period of the pendulum. So how do you determine the period of the pendulum? First of all, you need to find out the time. And these times are for the 20 oscillations. So first thing, you need to find the average time. So how do you find the average time? You simply add all these times which are given here. You add them. So we're going to say average time taken will be equal to what? You add your 16.1 plus 15.9 plus 16.0 plus 16.2 plus, let's move it a bit, plus our last time, which is what? 15.8. Like that. So after you have added the time there, you're going to divide the sum or the time you have been given by the number of frequency, by the frequency of this time. So when I say frequency, what do you mean? You simply count the times given. How many times are there? You have 1, 2, 3, 4, 5. So we're going to divide by what? By 5. The summation of this time given. So we're going to say equals there. Then you get your calculator. Then you punch in your calculator the values which have been given, these ones here. You add them. So we're going to say 16.1 plus 15.1 plus 16.0 plus 16.2 plus 15.8. Then what do? You add them. You're going to get what? 80 as your total. So I've gotten our 80 there. Then we're going to divide with the number of times. These times were given. How many are there? There are 1, 2, 3, 4, 5. So we're going to divide the total, this is on top, by 5. So here I've written 80 divided by what? By 5. So when you punch in your calculator, when you say 80 divided by 5, you're going to get what? 16 seconds. That is your what? Your time, your average what? Time. So after finding your average time, what do? Go back to the formula saying period is equals to time taken over the number of what? Number of oscillation. So the time taken we found is what? Is 16 seconds. Then our number of oscillation have been given in the question, remember, which is here 20 what? 20 oscillations. So you divide by 20. So this is going to give us what? 16 divided by 20. It's going to give us 0.80 seconds as our period. So that's how you find our period. Okay, so we move on to the following year, which is 2016, if I'm not mistaken. 20, okay. So we have done 2015, we're going to 2016. Remember, we're doing revision on measurements, only measurements. So we're going to look at 2016 November, which is pure physics. 2017 November, the question on what? Measurements. Okay, so the question reads, figure 1.1 shows a vernier caliper being used to measure external diameter of a metal tube. Okay, so we have our vernier calipers, which is here. The question A1 reads, what is the measurements indicated in the diagram? What is the measurements indicated in the diagram? So how do you read the vernier calipers? So first thing, you need to find what? The data. So the data you need to find is what? So I'm going to say data. The first thing you need is what? The vernier scale reading. You need to find that one. Then secondly, you need to find what? The main scale reading. Okay, so now the question here is, how do you find the vernier scale reading and the main scale what? Reading. Okay, so for example, I don't know if it's visible there. I'm going to draw a brief diagram here to show. So let's say this is our vernier calipers. Then you have our vernier scale there. Then here you are going to have let's say 2, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it should be 3 there. 3, just like that. It continues. I hope you can see there my diagram here. Then I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so you have a 5 there. So this is the other way the question can be presented under our vernier calipers. So how do you determine the vernier scale reading and the main scale reading when you're given a vernier calipers, which is this one here? So the first thing, you need to identify which one is your main scale. So your main scale is simply this one, which is on top here. This is what you call what? Your main scale. Then the linear scale is simply this one and this down part here. Then they can interchange. They can interchange. This one can be on top. That one can be on at the bottom. So how do you identify this one is the main scale and this one is the linear scale? The linear scale will always start from 0 up to 10 only. That's the linear scale. Then the main scale will always have different readings. It doesn't end on 10 like this one, the linear scale. So that's another way you can differentiate the two there. So after doing that, what do you do next? You get your main scale reading. So how do you get the main scale reading from this? So your main scale reading is gotten by where before the 0 mark or the linear scale. So this is what we've decided. We have already discussed that this is our linear scale. And to find a main scale reading, we have to go where the 0 mark is for the linear scale, and the linear scale, the 0 mark for the linear scale is here. So once you go to the 0 mark for the linear scale, what do? You look at the figure which is before the 0 mark of the linear scale. In this case, is what? It's you need to count here from top. You have 2, 2.1, 2.2, 2.3. So before the 0 mark here is what? 2.3. So our main scale reading will be what? 2.3 centimeters, like that. So once you have done this, you need to find what? Your linear scale reading. So how do you find your linear scale reading? You go inside here, the linear scale box here, or where the linear scale reading is. So what do? You're going to look at these readings which are here, these demarcations which are shown here. So these, you need to check the one which is in a straight line with the one which is on top, like this line which is here. You need to check which other line which are on top. Is there another line? Like for example here 1, the linear scale is 1, right? You check on top here on the main scale. Is it corresponding with any other region on the main scale? It's not. This one is not. This one is not. This one is not. But this one 5 is corresponding with another region which is on top of it. In other words, they are forming what? A straight line. So immediately these lines which are in the linear scale and the lines which are on the main scale form a straight line. Just know that it's your what? It's your linear scale reading. In this case, 5 here is forming what? A straight line. Pardon the background noise. So here, what is forming a straight line is what? Is the 5 reading here is forming a straight line. That will be what? Your linear scale reading. But remember, the linear scale is what? Is measured in what? In millimeters. While this one is measured in what? In centimeters. So here, your 5 is in what? So it's 5 millimeters. But we need to convert this into what? Centimeters. So how do you convert this into what? Centimeters. You simply multiply the figure I've gotten there, the one which is corresponding, which is forming a straight line, you multiply it by 0.01 centimeters. So this is how you convert millimeters into what? Centimeters, by simply multiply the figure I found there by 0.01 centimeters. So using a calculator there, what are you going to do? You're going to say 5 multiplied by 0.001. So we're going to get 0.05. So I'm going to write it here. I'm going to say 0.05 centimeters. So this is what the final reading on the linear scale. So what do? Once you have converted the millimeters into centimeters, you add the 2 to find your just move for space. So to find your final reading, what do? You simply add the linear scale reading plus the main scale reading. So our linear scale reading we found here is what? Is 0.5 centimeters, and our main scale reading I found is what? Is 2.3 centimeters. What do? Simply add. Then we're going to have 0.05 centimeters there on top, also at the bottom there on centimeters. Then you add. So after adding, you're going to say this plus this. We're going to say 2, then this centimeters there. So that's how you find the reading on the calipers. So now going back to the question which came in 2016 November, paper 2 physics. I've been asked what is the measurements indicated in the diagram. So what do? Sorry for that, it was a bit unstable. So looking at the question which came in 2016 November, paper 2 pure physics. Our reading here, we have to find our reading in this box here. How do you find our reading? You simply check. First thing, you need to get your data. First thing, you need to collect your data. So how do you collect your data? Say data. You need to find the main scale reading. So main scale reading here is what? If you check it on the diagram, on the given diagram here, the mark before the zero, the mark before the zero on the main scale reading is what? 1.1 centimeters. That is our main scale reading, 1.1 centimeters. So what do? You need to find the vernier scale reading. So how do you find the vernier scale reading? You look at the question again, just like this. Look at the question. Now you need to go inside this vernier scale reading. So you look at the number which is forming a straight line, and again this one is also what? Forming a straight line with which number? 5 here. It's forming a straight line with 5. So our vernier scale reading is what? Is 5. But you need to convert this 5. Remember, since it's in what? In millimeters. So it's 5 millimeters there. You're going to multiply it by 0.01 centimeters. Why? Because you need to convert these 5 millimeters into what? 2 centimeters. So we're going to say the vernier scale reading will be equal to 5 millimeters times 0.01. You're going to get 0.05 centimeters. So after finding the vernier scale reading, what do? You need to find the final reading. So a final reading will be what? You need to add the main scale reading plus the vernier scale reading. Okay. So looking at what we have found here, our main scale reading is what? Is 1.1. So we're going to say 1.1 centimeters. Then our vernier scale will be what? Be 0.05 centimeters. So it'll be 0.05 centimeters. Then you add. So when you add here, you're going to say this 1 plus 0 is going to give us 1. Then 1 plus 0 again give us 1 plus 5. Just drop the 5 there and put the correct. When you put the correct units, which should be 1.15 centimeters as your final reading. So we have answered question. Question what? Question A1. We move on to question A2. So question A2 is asking us to calculate the volume of a tube. Take pi is equals to 22/7. So how do you calculate the volume of the tube? You need to remember the volume. The formula saying volume of the cylinder So if you look at the diagram here, we are dealing with a what? We are dealing with a cylinder. So we need to find the volume of the what? Volume of the cylinder. How do we do that? We know that the volume of the cylinder is equals to pi 2 pi r squared times what? Our height. So this is the formula for volume, pi 2 r squared times height. So if you look at the question here, our pi we have already been given in the question our pi. Our pi is 22 divided by what? 7. Then how do you find our radius? So to find your radius, you simply divide the answer we have found on A1 here. The reading, this one I found here, you just simply divide it by 2. Why? Because remember, the linear pass is used to find the diameter of the object. So what we found there, so it was a diameter, and we need to find out our radius. So we're going to say 1.15 divided by 2. This is going to give us what? 0.57. 0. On the calculator there, when you divide 1.15 by 2, it's going to give us 0.575. That's how you get your radius. So then substituting the formula there, in volume is equals to our pi, we already know it's 22 divided by 7, multiply it by 2. Then our radius is what? 0.575 to the power 2 times our height. So where do you get your height? If you look at the question here, our height is what? Is this one here. This is our what? Our height, which is 4 centimeters. So multiply by 4, just like that. So what do? You punch in your calculator there. You're going to say 2 open bracket 22 by 7. That's our pi. Then we're going to multiply it by open bracket 0.575 to the power what? To the power 2. To the power 2 there, we're going to multiply it by what is 4. So our answer will be what? Our volume will be equals to 0.312857.143. Then you round it off to 2 decimal places. This is going to give us 8.31 centimeters cubed with the correct units. Don't forget the correct units there. So once you have done that, we'll move on to the next question. So the next question reads, given that the cross-section area or the shaded portion of the tube is what? Is 0.5 centimeters squared. Calculate the volume of the material of the tube. Okay, so just using different types of formulas for volume. So this is A2. Now move on to question B1. And I've been asked to do what? To calculate the volume of the material of the tube. So we know that volume is equals to base area times what? Times height. So volume is equals to our base area have been given in the question here. Where is it? It is this one here. Our base area. So what is 0.5 centimeters multiplied by what? Our height. Our height have already been given in the question, which is here from there to there, which is what? 4 centimeters. So 4 centimeters there. Multiply it. So we're going to say volume is equals to 0.5 by 4. We're going to get what? We're going to get 2 centimeters cubed as your volume there. So the question goes on saying, move on to B2. Question B2. So question B2 reads, the mass of the tube was measured by an electronic balance as shown in figure 1.2 below there. So this is the diagram showing the experiment. The mass of the tube was measured by an electronic balance shown in figure 1.2 below. So what's our mass showing on the diagram there is 15.6 grams. So the question is asking us to calculate the density of the material of the tube. So how do you calculate density? We're going to use the formula for density. We know that density is equals to mass over volume. So here the volume we're going to use, if you read the question, calculate the density of the material of the tube. Calculate the volume of the material of the tube. Okay, so here our volume, I'm going to use this one I found. Let me just do this. So the volume I'm going to use on the formula for density here. Our mass we'll get from the diagram given, and our volume we're going to get from question B1. Why? Because it's saying calculate volume of a material or the tube. If you look at the question here, it's also asking us to do what? To calculate the density of the material or the tube. So that's why we're getting the volume from there. Then our mass will be this one here. So to find our density, we're going to say density is equals to, what's our mass? Our mass, if you look at the diagram here, our mass is 15.6 grams. 15.6 grams divided by the volume of found, which is this one here, which is 2. So divide that by 2. We're going to say density is equals to 15.6 divided by 2. We're going to get as your density is equals to 7.0 grams per centimeters squared. So this final density will be 7.8 grams per centimeter squared. Okay. Looking at the last question there, the last question reads, name the material the tube was made of. Name the material the tube was made of. So the material which is the tube was made of, it was made from iron. That's how you answer that one. So I'll move on to the following year, which is the 2016, which is GCE 2016 GCE. Okay, so the question reads, the figure 1.1 below shows a vernier caliper indicating a measurements. So I didn't again have any caliper indicating what a measurement. Okay, so figure question A1 reads, which jaw A or B can be used to measure the thickness of the wire nail? So between this one and this one, which jaw can be used to measure the thickness of the wire nail? So the thickness of the wire nail which can be used is A, jaw A. Why? Because it is very small compared to this one here. So we move on to the next question, which is question A2. Question A2 is saying explain the function of a vernier scale in this instrument. So the vernier scale is simply to record the vernier reading, to give us what the vernier scale reading. That's the function of the vernier scale. So we move on. What is the reading indicated in the diagram? So we need to repeat the same process again, the one we did in the previous question. So we know that final reading on a vernier scale is equals to what? Is equals to main scale reading plus vernier scale reading. Okay, so we need to find out our main scale reading and our vernier scale reading. So our main scale reading will be equal to what? The main scale reading is always the scale which is on top here. That's the main scale reading. So how do you find the main scale reading? Just go where the 0 mark is for the vernier scale reading. So the 0 mark is here. What's the number before the 0 mark is what? 1.2. So that's our our main scale reading, 1.2 centimeters. Then our vernier scale reading will be equal to, look at the vernier scale there in the diagram there. What do? You go to the reading or the number where it forms a straight line. So if let's look at this the vernier scale reading here. So does 5 forming a straight line? It's not forming a straight line. So let's start with number 1. Let's look at number 1 in the vernier scale there. Is number 1 showing any straight line? It's not. Number 2, it's not. Number 3, it's not. Number 5 is not. Then number 6, if you pay close attention there, is forming a straight line. So that will be our 6 millimeter. Then we're going to multiply this by 0.01 centimeters. Why? Because we want to convert the millimeters into centimeters. So what do? Multiply the two, get your calculator there. We're going to say 6 by 0.01. It's going to give us 0.06 centimeters as our vernier scale reading. So what do you do next? You need to add this. What do you do next? You need to add this figure and this one here to get your your final reading. So here we're going to say 2.2 plus 0.6 centimeters. So our final reading will be what? Final reading will be equals to 2.26 centimeters, like that. So we have answered question A3. So now we move on to question B1. So what is question B1? Question B1 So question B1 here is asking us to do what? In the space below, draw a section of the micrometer, screw gauge, sleeve and thimble sections showing a measurement of 4.35 millimeters. Okay, so we need to draw the section which is showing that. So how do you do that? So we know that the instrument we have been given in the question is what? The micrometer screw gauge. We know that the micrometer screw gauge has what? The sleeve and the thimble sections, right? So these are the main things you should concentrate on when drawing. So we're going to draw the sleeve scale and the thimble scale. Okay, so I don't have the ruler, so my drawing will be a bit rough. So it will be a straight line like this. This will represent the sleeve scale. Then we're going to have our thimble scale, this one here. Then we're going to put the numbers there. So in the question here, I've been told to show the reading of what? 4.35 millimeters. Okay, so we can start from here. We're going to say this will be our 1. Okay, label this as our 1. So we're going to have 1. Then here we're going to have 1, 2, 3, 4. Then here are 2, 1, 2, 3, 4. Then here our 3. Then 1, 2, 3, 4. Then our 4 there. So this will be our 4. I hope it's clear. We have a 1, 2, 3, and 4. So what do? We also need to create another thimble scale reading. So here, the reason why I've ended on 4 is because the first figure there is what is 4, and this is what the slave scale. So automatically this is what the slave scale. So what do we need to do next? We need to find the 35 millimeter reading. So how do you do that? So this line here, which is here, needs to be at 35. So we can start from any place here, just bar, roboted bar. Keeping in mind that this one have to be what? 35. So we can say 35. This will be 34, 33, 32, 31, 30. Then there 36, then there 32, then there 36, there 37, then there 38. Okay, so this is how you show the section of the micrometer screw gauge, showing this reading of 4.35. Okay, so what do? We move on to the next year. Which is 2017 GCE. So 2017 GCE. So the question reads, Elena carried out an experiment to determine the density of ethanol obtained the following results. The learner used a bottle of known volumes. So I have a mass there of bottle of known volume. Mass of empty glasses bottle is equal to this, 242 grams. Mass of bottle filled with water is 902 grams. Then mass of the bottle filled with ethanol is what? 857 grams. So what do you do? Question A1. So question A1 reads, what mass of water was used to fill the bottle? What mass of water was used to fill the bottle? So here, how do you find the mass of the how do you find the mass of the water which was used to fill the bottle? So simply here, get the mass of the empty bottle there, right? Then you get the mass of the bottle when it was filled with water. Then that mass you subtracted when the bottle was empty. So in this case, we're going to say 992 grams minus 242 grams, like that. So that's how you find your mass of that's how you find the mass of the water. So then after getting your calculator, as you do, you're going to say 992 minus 242. You're going to get what? 750 grams as your mass of water. 750 grams as a mass of water. So what do you do next? We read the next question. So the next question is asking us to do what? What mass of ethanol was used to fill the bottle? What mass of ethanol was used to fill the bottle? So here you repeat the same process, but in this process we're not going to use the mass of the bottle filled with water. No, we're going to use the mass of the bottle filled with ethanol. Why? Because you have asked us to find the mass of what? Ethanol in this case. So we're going to say the mass of the bottle filled with ethanol is what? 857 grams. So we're going to say 857 grams minus the mass of the empty bottle, which is what? 242 grams, like that. So what do? You're going to say 857 minus 242. We're going to get what? 615 grams as your mass of ethanol, which is A. Okay, so the question continues saying to question C. So question C reads, calculate the relative density of ethanol. Calculate the relative density of ethanol. So how do you calculate the relative density of ethanol? So relative density is simply the mass of ethanol divided by the mass of what? The water. That's how you find the relative density of ethanol. Relative simply coming from the ratio. Just compare the mass ratio of the water to the ratio of a substance. In this case, what substance are they asking us to find? They're asking us to find the ethanol. So relative density of ethanol will be what? So we're going to say RD, representing relative density, is equals to mass of a substance we're going to divide this by the mass of water. So this is the formula for finding what? Relative density. So here we already know the mass of what? Of ethanol, which is 615 grams. Right? So we're going to divide it by what? Mass of the water. In this case, what did we find? We found what? 750 grams. So we're going to divide 750 grams. This will be equals to, so we're going to say 1615 divided by 750 grams. So it's going to give us what? 0.8. Remember, relative density has no units. Why? Because it's a ratio. That's why it has no unit. It's a ratio. That's why it has no units. This will cancel with that one. Within the answer with what? No unit. Move on to the next question, which is the 2017 paper 2 physics 2017 paper 2 question 1. In this video, just concentrating on measurements, revision on measurements, a topic what? Measurement. So the question reads, figure 1.1 is a full scale drawing of aluminium bar. So this is a full scale drawing of the what? The aluminium bar. So the first question is asking us to what? Calculate the volume of the bar. So how do you calculate the volume of the bar? You simply multiply the base, the height, and the width. The base, the height, and the width. That's your volume. So in this case, we're going to say going to say 2 by 2 by 5. So our volume will be what? 20 centimeters cubed. Moving on to the next question here is saying, what other measurements are needed to determine the density of aluminium? Okay, so for you to know what other things which are needed, just going to use the formula for density. We know that density is equal to mass over volume. Do you have a mass? We don't have. Do you have a volume? A volume we found is what? Is 20 centimeters what? Cubed. So we need to find what? Mass. So what other measurements are needed? So the other measurement is needed is what? The mass of the aluminum bar. Why? Because if you want to use the formula for finding density of the aluminum bar, you're going to need number 1, the mass and the volume. But the volume are found by multiplying 2 by 2 by 5. That's how you find the volume, but the mass haven't been given. So the other thing you should need to calculate the density is what? The mass of the aluminum bar. So moving on to the next question here is, when placed on a measuring pan, a reading of 56 grams is obtained. On figure 1.2, draw a pointer showing a reading of 56 grams. Okay, so on this figure, we need to show the reading of 56 what? 56 grams. So how do you show the reading on the diagram there? Okay, see here we have the camera, just a bit, and just focus it. Okay, so here we have our 55 there. Hope you can see now. We have our 55 reading, and I've been asked to draw the 50 what? The 56 grams on this diagram. So how do you do that? So you're going to start from here, then we know in between. How do you count? So this one will be 51, this one will be this will be 51, this will be 52, 53, 54, 55. So 56 will be here. So just draw the pointer from here, pointing to here, then you get your mark here. So find the density of the aluminum bar. So how do you find the density? We're going to use this formula here, saying density is equal to the mass I found already by multiplying this or by volume. Sorry, the volume already found by multiplying this by that, give us 20 centimeters cubic, 20 centimeter cubic, and our mass have been given is what? In the question here is what? Is 56 grams. So our mass is 50 what? 56 grams divided by 20 centimeters cubic. So 56 going to divide it by what? By 20. It's going to get 2.0 grams per centimeters what? Cubic. Okay, so we're going to end here in 2017. We're going to continue tomorrow. Thank you for watching.